Hi everyone, let me introduce myself. This is Ashna Kothari here. So in this particular lecture, we shall be discussing a question which had recently come in CS2 examination, paper A. It's from Markov Chain. So far, I guess I have interacted to close to 70 to 80 students regarding this question just to get some idea, if any one of them was able to kind of attempt this question or solve this question in examination. So far, not even one mentioned about it. I also inquired a couple of them, if you after the exam tried to solve it, then they were like, exam is done, they don't want to spend more time because overall the exam experience for CS2 was not that good, as many of them did find paper difficult or lengthy, be it paper A or paper B. So in this particular video, what I'm gonna do is discuss this question one primarily on the transition probability. As we all know, the heart of Markov chain lies in being able to create the transition matrix or the transition graph. Once you have that, things becomes pretty much easier. Now, post the exams, I did come across certain posts over social media like LinkedIn where students had raised certain petitions claiming that overall paper was difficult. Not getting into that part specifically, there was a mention about that certain questions did come in exam which were not there in the material or so. So, honestly speaking, when you're giving an exam, especially a professional exam like actuarial science, it's not what used to happen at school level, that you have a book, you have questions there, you practice them, and then you expect same type of questions to come. Specifically for CS2, that is not going to happen. It's your ability to apply the concepts in different scenarios. So in this question, if once we have discussed, all one needs to know is forget transition probability once. We just need to compute probabilities. Anyone who has studied probabilities at class 11, 12, or at any stage of their academic life, they would understand what I'm doing in this video. So it's not that you need to have studied CS2A. Obviously, if you need to know, have, let's say studied CS2 so that you know the meaning of transition probability matrix, but let us ignore it. Our focus is how to go about computing the probabilities and how do we infer what the question is saying. So only two things we need actually for this question. One, the ability to interpret English, which is there for all exams, given that English is the mode of examination. Again, might sound very trivial or a bit nonsense what am I saying, but we need to really understand what the question is saying, especially for Markov chain. It tends to happen that sometimes the way we interpret the wordings of the question, things can come out a bit different. And secondly, you need to understand probability. That is all we need. So I guess, most of you, if you watch this video completely till the end, you would understand that, okay, this question was not something difficult. Yes, it was difficult to get it correct in examination when the pressure is there. You need to complete the entire paper. But again, this is not the question you should be attempting at, the first question to attempt. Once you're done with the questions, in examination, you have time remaining, you could definitely do it. So when I was going through this question, I started solving the other questions first. I'm like, this is Markov chain. This might take a bit more time, so I will come back to it later. And once I went through the question, if I recall correctly, it took me just 7 or 8 minutes to get a hang. Obviously, another 10-15 minutes to consolidate it and put the results in a, what to say, in a very proper format, which we had released as, CS2A solutions video. But overall, just to get an essence, how it works. Because honestly, my initial estimate or my initial thought after reading this question was, "Kya hai? What is this?" And not being able to completely imagine in my head. Obviously, through practice, I expect that most of the questions by reading it, I can have a mental picture, as to how to start from where, how it's gonna end. But for this question, I didn't know how it's gonna end. So that was the case. But again, this was doable, and I'm pretty sure that many of you, would feel that okay, after this watching this video, you will be like, okay, this question we have completely understood. Again, if a new question comes in examination, you might not be able to crack it, but you should at least understand the logic behind all of this. So the more you practice, the more logic you get, more is your ability to, apply it if something new comes. At least if something new doesn't come, something similar comes, you at least know how to go about it. So now starting, let us read the question, because for these type of things, keep reading the question till you don't get exactly what is happening. A process xt is created as follows. n black balls and n white balls are initially placed in two separate boxes A and B in such a way that each box contains n balls. An experiment is performed in which a ball is selected at random from each box at time t, and the two selected balls interchange. So let's say we have a box A and then we have another box B. N balls have been put together. At each point of time, we select one ball from box A, another ball from box B, and we kind of interchange it. That's what we are doing here. Let xt, which is very important to understand how the process is being defined. Let xt be the number of white balls in box A just after time t. Now, first thing you should have in mind is what the process says is the number of white balls in box A just after time t. So in total, there are n white balls, n black balls. So in any, let's say in box A, you could either have 0 white ball, 1 white ball, 2, 3, so on till n. So this gives you the clue, or let's say directly the point that there will be the state space are going to be 0, 1, 2, 3, so on till n. Now again, depends, what time t it could be, what could be the starting point. On that basis, it could actually vary. But for all possible times, this is gonna be my sample space. 0, 1, 2, 3, so on till n. Now, then it's mentioned, assume that all n balls were initially in box A, were the white balls. So initially in box A, all of them were white balls. And all the n balls that were initially in box B were the black balls. Again, although I'm reading this out, this is for part 3. My major focus is on part 2. So for the time, let us ignore it. Now, at time t, how many white balls can I have in box A? It could be 0, it could be 1, it could be 2, 3, 4, 5, 6, so on till n. There are two ways to approach this. Initially in my academic life, when I was at school level or even at college level, I always had this thing, let me put a value of n and then let me try to visualize it. And then I can generalize it. Once I started teaching, I felt that, sometimes for certain students, giving an example is fine, but then they sometimes find it difficult to generalize it. For me, it was easy. Like once I've got an example, I've got an expression, I know this is my truth. So now I get a generalized expression, and even if I'm not very much comfortable with it, I know this is the source of truth because, this is the pattern and this should be there. So I will try in this video to explain in both the ways. Generalized way obviously is important. You can start with that. Alternatively, you can take a value of n. Let's say 2, 3, 4. This is a bit more, let's say, linear, but usually that is how you crack it if you're not getting the generalized way, which I guess most of you might find it difficult. So two approaches, both leading to the same conclusion as it is. One is just to put a value of n just to understand in your mind, what exactly is happening. And another is we work with n only. So let me start with the generalized way, and I hope that it should be clear to every one of you. As let's say your own self class for homework, you could take the value of n, let's say to be 2 or 3, and then you can work around. Taking one also is fine, but then you will not cover all different type of cases. I'll say at least take the value of n to be 2 or 3, and then you can see how structure is there. And that's always a good self check. Because once I get a general expression, I put a value of n, I will see what my general expression is giving me. And then logically, let's say if I've taken n 2 or 3, I can compute the required probabilities and then cross check whether it's consistent or not. Okay. So here, let me first take you all through the solution just to get an idea. This is all we need, consolidated form, these three lines. Now, obviously, you might be thinking these three lines fetching 6 marks. I mean, getting these could be very difficult. You obviously need to explain it in words as well in examination. So what I want to see is whatever your current state is, in the next possible time, the value can either remain the same, that is the number of white balls can either remain the same, it can increase by 1 or it can decrease by 1, or depending on, currently what value is going to be there. Okay. So supposedly, right now, we'll just assume that we're not taking the extreme cases. That is, we do not have n white balls or 0 white balls, because in those cases, these would not be valid. So this is slightly incomplete. These set of probabilities are valid as long as A does not take the value 0 or n. Because when A takes the value 0 or n, we'll have a different set of probability altogether. So now let me walk you all through, what is the thought process, how it's working, so on. There is box A over here and there is box B over here. So there are n balls over here, 1, 2, 3, so on. And over here also, there are n balls. Now, obviously, if you take some value of n, it becomes more easily to visualize. But let me try the general way itself. At any point of t, at time t, I say that box A has A balls. Box A has A white balls. And I am for the timing assuming that A is neither equal to 0 or n, because this will be the extreme case. We'll take a look at it slightly later. So there are A white balls in box A. Okay, so how many balls will be not white? This is box A white. Since there are total of n balls, it will be n minus A non-white. What do we have given in the question? Is it white or black? So it's given to be black only. So let's say n minus A black. Now in box B, since A white balls are there in box A and total n white balls are there, therefore n minus A white balls should be in box B. And similarly, if there are n minus A black balls in box A, it means that there should be A black balls in box B. Okay, now what we do, we pick one ball from A, we put that to B, we take one ball from B, we put that to A. So what could be the possible permutation and combination? We can select white from here, white from here, white from here, black from here, black from here, white from here, black from here, black from here. In the first case, I am taking one white ball, putting it to B. I am taking one white ball from B, putting it to A. So I initially had A white balls in box A. I still have A white balls in the first scenario. In second scenario, I took out a white ball from box A and I took a black ball from box B and put it in box A. So now I will have only A minus 1 white balls. In this scenario, we are taking out a black, we are putting in a white. So we would be having A plus 1 white balls. And over here as well, I'm picking up a black ball and I'm putting also black ball. So this will also be nothing but A white balls. So what you see is if currently box A has 8 A white balls, in the next time at t plus 1, it can either take the value A minus 1, A plus 1 or A. How do we get the probability? What's the probability of picking a white ball from box A? There are A white balls and there are total of n balls. So way in which we can pick up, like if you want the probability, it will be nothing but simply A by n. A by n is the probability that a white ball is picked up from n balls. And over here as well, I need to select a white ball. How many are there? N minus A. So n minus A by n. This corresponds to first case. Second case, white and black. So this will be A by n. How many black balls are there? A. So this will be also A by n. This we pick up black. How many black are there? N minus A by n. We pick a white. How many white are there? N minus A. And over here we pick a black, we pick a black. So this will be coming as n minus A by n into A by n. So if you consolidate this, what you see is for A minus 1, the probability is coming out to be nothing but A square by n square. For A plus 1 is coming out to be nothing but n minus A whole square by n square. And for A, it's coming out to be 2A n minus A by n square. A check is always that this addition of all of these must add up to 1, and that will be the case. You can think this to be A, which is A only, A square. N minus A you can think as B, A square, B square, and this is nothing but 2AB. So if you add the denominator A square plus B square plus 2AB, it will be A plus B whole square, which is A plus n minus A, which is nothing but n. So n square by n square is nothing but 1. So these are self checks you need to make. ones who are already working in an actuarial setup, or let's say a non-actuarial setup, you must understand how important it is to, generate self-checks. So these are the self-checks even you are solving in an examination, you can do whether this is making sense or not, the particular value you're getting. Because what it helps is, if it's not adding up to one, means definitely we have made some mistake. What mistake we might not know, but we will definitely know there's a mistake. So we can go back and try to rectify the mistake instead of going on with wrong set of calculations or wrong set of assumptions. So as you will see, xt a plus 1 n minus a whole square by n square, xt a minus 1 a square by n square, and taking the value a, 2a into n minus a by n square. This will be holding true when a is not taking the value 0 or n, because that is the extreme case. Because if a takes the value 0, okay, then it cannot take the value minus 1. So in the extreme case, what is going to happen is, you can think this way: if a is 0, means the box A has 0 white balls, all black balls, which means box B has all white balls. So once we make a transfer, it definitely means that probability xt plus 1 is equal to 1 given xt is equal to 0. This is nothing but has a probability of 1 only. In fact, I guess even from here, mm, I guess we might get this from here as well. Let me just see. If a is taking the value 0, so this becomes 1. I have n minus a whole square by n square, which becomes n square by n square, and it takes the value 1 only. And automatically these two will take the value 0. So this would be giving probability xt plus 1 equal to minus 1, given xt equal to 0. This will be giving nothing but 0 only. So even the 0 condition is something, I guess this is satisfying. Let's take the extreme and n. If this is n, this cannot take n plus 1. It should be 0. And over here also we'll be getting n minus n whole square, which is again nothing but 0. Again, it cannot take the value n. Why? If box A has all white balls, it means box B has all black balls. Once we make a transfer, then box A must definitely have n minus 1 white balls. And this xt plus 1 equal to n minus 1, this will be taking the value what? A square by n square, a is nothing but n square by n square, which is nothing but 1. So in fact, we see, usually you might think at experiment things might work a bit differently. Over here, we see that actually these three equations summarize the entire thing and you get the transition probability. So this was the explanation. I hope that all of you were able to explain it. As another way to understand, you might take the value of n as 3 just to be able to visualize, okay, what is happening. 3 white balls, 3 black balls, you pick up, it becomes easier to visualize. With n, it becomes slightly difficult. So hope that you all did found this video useful. So once preparing for actual examination, CS2, or for ones who like to solve puzzles, I will definitely go on and say that Markov chains are nothing but sort of mathematical puzzles. It's something I really enjoy. Obviously, on the day of exam, I might not enjoy it because there is stress whether I can solve this question or not. But as a teacher, it's always fun to take a look at these questions and then challenge yourself. Let's try to get it. And the good part is the solutions are not available till the examiner report is there. So there is no way, I can give up and just take a look at the solution. Because trust me, as a teacher, I know once I have the solution, it's very easy to explain, what is happening, why it is happening. Obviously, not all of you would be in that position, but if you'll ask me, cracking the question is one part of it, explaining it to students is another part. Sometimes you might not have the ability to crack the question because that requires you to solve it accurately in a time bound manner. Explanation part is something else. Like, you once understand, maybe you didn't get it right yourself, you took a look at the solution, and then you know how it needs to be done, and then obviously it's how you communicate to the other one. So how I think about it, like when I'm solving the question, it is more about testing my technical ability or my conceptual ability, I will say. More so my technical ability to solve these numericals, derivations, so on. When it comes to explaining it to my students or anyone else, it's more about my communication ability, how well I can communicate what I have understood. At times I might understand things very well, but there could be a difficulty in trying to explain the students' part as well. So, sometimes, when I talk to my students, they tend to complain a lot about the professors in college, ki they seem to be very highly qualified, especially ones who are studying at very clean colleges, or let's say ones who are studying at IIT or IIM, a couple of them. So they say, my professors are very knowledgeable, they have so many degrees, but they cannot explain. So this is a kind of an issue which certain of us might have, a lot of them in the teaching, let's say, profession, where things very well, but you cannot explain it. So that also does not serve the purpose, because ultimately our task is to ensure that whatever students are asking, they are understanding even the more difficult things. So that is all from my end. If you did find this video helpful, please do like this video. If you want to ask any queries regarding this question, anything, feel free to reach out to us to the comments section. And don't forget to subscribe to our channel so that you are updated with all the latest educational content we release. Thanks everyone. Thanks for watching this video.